Now we are going to discuss some properties of a vector. How can we represent a vector in R sphere in RQ plane? So the first one is vector in R sphere and RQ plane or geometry. So the vector in R sphere is denoted as vector x with component x1, x2, that is in x-axis direction and that is in y-axis direction, and in R cube space as vector x is equal to x1, x2, x3, where x1 describes the direction component in x-axis direction, x2 in y-axis direction, and x3 in z-axis direction. So if we say a point P lie in R cube space, then we can take the component P as x, y, z. Now we will discuss the second concept, that is equality of two vectors. In R square and R cube. As we know that in R square, if two vectors x1, x2, that is vector x with component x1, x2 and vector y with component y1, y2 will be equal if and only if their corresponding components are equal, that is x1 is equal to x2 and y1 is equal to y2. Similarly, in R cube, if two vectors, that is vector x with component x1, x2, x3 and vector y with component y1, y2, y3 will be equal if and only if their corresponding components are equal, that is x1 is equal to x2, y1 is equal to y2 and y3 is equal to, x3 is equal to, that is x1 is equal to y1, x2 is equal to y2 and x3 is equal to y3. That is, two vectors are equal if and only if their corresponding components are equal. That is, x1 is equal to y1, x2 is equal to y2, x3 is equal to y3. Component of in x1, x, y and z direction. And the next is, that is sum of two vectors. In R square and R cube. Now here we will see how can we represent the sum of two vectors that are lying in R cube and R square. So if vector x is equal to x1, x2 and vector y is equal to y1, y2 belongs to R square, then their sum vector x plus vector y is equal to x1, x2 plus y1, y2. It will be get after adding their corresponding component, that is x1 plus y1, x2 plus y2. That is, we get a new vector that is called vector z with component x1 plus y1, x2 plus y2. That is, if we added two vectors, we get a new vector, vector z, which belongs to R square again. And also as if vector x with x1, y1 and z1 and vector y is equal to x2, y2 and z2, then we can take their sum as vector x plus vector y, that is x1, y1, z1 plus x2, y2, z2. Both these are belongs to R cube. Then their sum will be x1 plus x2, y1 plus y2, z1 plus z2. That gives a new vector, that is vector z, which is also belongs to R cube. So this is also we can say this is the closure property, which show that if two vector belongs to R cube, their sum is also belongs to R cube. We can take vector instead of x1, x2, x3 and y1, y2, y3. We can take x1, y1, z1 and x2, y2, z2. That is our wish. How can we assume the vector in R cube? Now next is multiplication of a scalar. With vector. So how can we multiply a scalar with a vector? And what happens when we multiply a scalar with a vector? After multiplication, it becomes a scalar quantity or a vector quantity. Let's see. Let vector x is equal to x1, x2, x3. You can take x1, y1, z1. That's your way. And suppose k belongs to real number, then we have to check k into vector r, that is k into x1, x2, x3 is equal to k times x1, k times x2, k times x3. That is again a vector that belongs to R cube. Therefore, if k belongs to R and vector x belongs to R cube, then after multiplication, kx times vector belongs to R cube. So after multiplication, a vector becomes a vector quantity, and this scalar will be multiplied by each component of a vector.